All right, ladies and gentlemen, welcome back for another session of Math Enjoyment with Mr. Massey. Today we're going to talk about graphing quadratic functions that are already in standard form. Now, standard form for the layman person is something that looks like this. Ax squared plus bx plus c is a function of x. So whenever you see this f of x, this function of x, that simply means you're going to be graphing this thing. It no longer equals 0, it's going to equal f of x. When it equals 0, that means you solve. When it equals f of x, that means you graph the thing. All right? So what we're going to do here is we're going to identify our a, b's, and c's. Whenever we have something in standard form, you're going to look for these couple of key points. That's going to identify some telltale signs of our graph. It's going to give you the lay of the land, if you will. All right? So first things first, I've color-coded these things with my a, b's, and my c's. Now my a is simply going to be my leading coefficient. It's the coefficient in front of my highest exponent. In this case, it's going to be the guy right out in front. So my a in this point is going to be 3. I'm going to write that right there. All right? My b is going to be my guy next in line in front of the x to the power of 1. It's going to be this guy right here in orange. In this case, you're going to take the sign with them, so that's going to be a -6. And last but not least, we got to identify our c value, and my c value is the straggler, the guy at the very, very end, the guy with no variable, just my real regular number, and that's just a 2. All right? Now, once I've identified my a, b's, and c's, these are consistent throughout the quadratics in standard form. Everything's going to be in A, B, and C format. All right, so the guy in front's always your A, this guy's always your B, that guy's always your C. Now, to answer a few of these questions, just got to use your eyeballs and make some observations. No math needed for now. All right, so I'm going to need some help with this one, so help me out. The A value here tells you 2 things. It tells you if it opens up or down, and if it's skinny or fat. All right, it tells you 2 things. If it's a positive number, it opens up. If it's a negative number, it opens down. All right? So in this case, is A positive or negative? Yeah, all right, it's a positive. So this one's going to open upwards solely because A is positive. Solely because A is a positive number. All right? Positive A. The next one, it says this one's going to be skinny or fat. So check this out. If this number here, positive or negative, is a whole number, like 2, 3, 4, 5, 6, anything bigger than 1, it's going to be skinnier than my parent function. It's going to be more narrow. So it's going to be a skinny little graph. This guy here is larger than 1, so it's going to open up and it's going to be skinny, real narrow. Open up and skinny. This one says, what's the y-intercept? Can you identify the y-intercept in this case? We sure can. In this case, the y-intercept is always going to be my c value. In this case here, my c value is just this 2. We identified that earlier. So that's going to be my y-intercept. So this graph for sure is going to cross the y-axis at 2. I know it because that's my y-intercept. Now here's where the math kicks in. My axis of symmetry and my vertex. To find the vertex, I must first find the axis of symmetry. To find the axis of symmetry, it's a real sneaky little formula that looks like this. You got a negative b divided by 2 a's. Negative b divided by 2 a's. So in this case, here's my b. So I got a negative b, right, because b is -6, so negative 6, divided by 2 a's. In this case, my a is that 3 value, right? So to find my axis of symmetry, where my parabola, when graphed, is perfectly symmetrical, it can fold it right in half, this is my axis of symmetry, all right? So check this out. What happens to 2 negatives that are scrunched up back to back? They turn positive. Yeah, they do. So here I can make these guys positive, giving me a +6 over a +6. This just gives me that +1. So here at +1, somewhere along this line, is going to be my axis of symmetry, where x equals +1. That's going to be my axis of symmetry. The axis of symmetry is also the x value of my vertex. Now, to find the y value of my vertex, I'm going to use my orange marker. all I have to do to find the y value of my vertex, I have to plug in the x value here wherever I see an x in my original function. So here I have 3x squared minus 6x plus 2. What I want to do is I want to plug 1 in wherever I see an x and see what that reads. So here I want to say when x equals 1, what is my function? So here I should have 3, instead of times x squared, it's going to be times 1 squared, right? Minus 6 times 1, instead of 6 times x, plus 2. Once I evaluate that thing, whatever this equals to, that's going to be the y value of my vertex. So help me out. I'm going to need some help with this one. Here, if I do PEMDAS, I got to do 1 squared first. What's 1 times 1? 1. Yeah! 3 times 1 gives me a 3. Here, what's 6 times 1? 6. Yeah! So here I got 3 minus 6. Keep it moving. Here I got this plus 2. Nothing changes with this guy. Alright? So I got one more step. I'm almost home free. So here, 3 minus 6 is a negative 3, plus 2 gives me a negative 1. This negative 1 becomes the y value of my vertex. Negative 1. So, if I plot my vertex with my blue pen, 1, negative 1 reads 1, negative 1 right there. Alright? So, I got my vertex, I got my axis of symmetry, this dotted line, I have my y-intercept. Now I can graph this thing. So what color should we graph it in? Let's choose blue. So here, if I connect these two dots, I know this should be a parabola, so it should look something like that, give or take, minus the artistic ability here, something like that. Alright? But that's one side of my parabola, I need the other side. Well, if this is my axis of symmetry, this is going to be folded right over top of this thing, and it's going to reflect perfectly. So check this out. Here's how we're going to do it. If this is my axis of symmetry right here, right, and I am 1 unit to the left, well, its reflected point is going to be 1 unit to the right of my axis of symmetry. I'm going to say that again. If this is my axis of symmetry, this dotted line, and my y-intercept is 1 point to the left, its reflected image is going to be 1 point to the right of my reflected line. All I got to do is connect these dots, scoop, and there is my parabola. A real skinny parabola that opens upwards, it crosses the y-axis at positive 2, and it has a vertex of 1, negative 1. Alright? Now you've seen that example, let's talk about this example over here. Example number 2. So I've asked you the same questions on this one, but I'm hoping we can speed this one up a little bit. Alright? So keep in mind, these first two right here are just observations of your A value. Alright? So, looking at this one, does this guy open up or down? Down. Why do you say down? Because it's negative. That's right. Since this is a negative right here, this graph opens down. Alright? Is this graph going to be a skinny graph or a fat graph? Well, in this case, in this example, that was a whole number, so it's going to be a skinny little graph. In this case, we got a fraction, so it's going to be a fat boy. So here, this is going to be a fat old graph when it opens up. Alright? So we're looking for a fat graph that opens downwards. Alright? My y-intercept, what is it? C. Yeah, it's my C value. In this case, my C value is just a 1. So if I want to mark up my graph, I can already do so. I know it's going to cross the y-axis at positive 1. I know it's going to open down. Now, my blue pen, I got to find the axis of symmetry. What's that itty-bitty little formula that I use to find the axis of symmetry? That's right, negative b over 2a's. So what do we got for him, Johnny? We got a negative b over 2a's. Oh man, we got a fraction. Oh no. Not to worry, ladies and gentlemen. When multiplying fractions, if I have two of them, I can just multiply straight through the top and straight through the bottoms. Help me out. What's 2 times -1? That's a -2. What's 1 times 4? That's a +4. This guy here can be broken down to a 1/2 or just a 0.5. All right? So he's my guy on the bottom in my denominator. The guy on the top is just this -2. He just gets scooted right on over. So what we got is we got a -2 divided by a -0.5. That, my friends, is going to give me a +4. So here my axis of symmetry is just a +4. If you remember, whatever this is also my vertex. So at +4, this blue dotted line is going to be where my parabola folds over onto itself. All right? We're almost there. Hang in there. We're almost done. The people are going crazy. Can you feel the excitement? Yeah! All right. So all we got to do is we found my x value of my vertex, but I want to know the y value of my vertex. How do I find it? Plug it in. Yeah, I got to plug it in. So with my pink pen, let's scroll down over here. We got to plug this guy in. So instead of x squared and x and yada, 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 I don't want to know what it is with x. I want to know what it is with 4. So I have to substitute or plug in 4 every time I see an x in my function. All right? So help me out, please. I want to know what this is when instead of an x, it's a 4. So let's put on the old thinking caps and do some math and see what we got. Help me out. The order of operations in PEMDAS tell us to do parentheses, then exponents. 4 squared gives me a clean 16. Negative 1/4 times 16 just gives me a -4. You guys okay with that? Yeah. All right, cool. 2 times 4 gives me an 8, so I'm going to bring that 8 right there, right? So that's just an 8. Nothing funny happens with him. Then this +1, I'm just going to bring him down. You know, nothing changes. Nothing changes. So now I'm almost there. Let's finish this guy up. -4 plus 8, what do you got? That's a +4. Yeah, it is. +1, what do you got? That's a +5. Sure the heck is. So up here we got 4, 5. That's going to be my vertex. So 4, 5 looks like it's right about here. Right about there's 4, 5. All right. So this one here, it opens down, and it's going to be a fat boy. Something like that. All right, but that's just half of my parabola. How do I find the other half, Johnny? Ding, 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 ding. Tell him what he's won, the guy in the back over there. All I got to do is count my spaces. In this case, it looks like, let's do the math. 1, 2, 3, 4 units to the left. So its reflected point is going to be 1, 2, 3, 4 units to the right, right about there. Smack! So now, to reflect this guy, all I gotta do is just like that. There, I have my fat parabola that's wider than my parent function. It opens downwards, has an axis of symmetry at +4, crosses the y-axis at +1. That, my friends, is how you graph a quadratic function. Yeah. People are going nuts over here. Ah!